discuss about the work. Okay. Okay, there is two types of work we can say in mechanics: positive work and negative work. Okay, if you see expression of work, F or W is equal to F dot D is equal to F D cos theta. Okay, see, if we see the value of cos theta from 0 to pi by 2 or 90 degree, cos theta is what? It is positive. Okay, from pi by 2 to pi 90 to 1 degree, between this range, cos of theta is what? Negative. In the second quadrant, cos of value of cos theta is always negative. So if theta lies between 0 to pi by 2, then the work is what? Then work is positive. Okay. In second case, if theta lies between 0 to pi by 2 to pi, then work is said to be negative. Okay. Positive work, we have given example. Okay, but what is the example of negative work? Okay, suppose example of negative work is work done due to frictional force. Okay, work done due to frictional force. Okay, or any resistive force which opposes the direction of so, or we can say negative work as any work or any force which work done due to any force which opposes the motion of a body. Okay, which opposes the motion of a body are called negative work. Okay, any force, okay, which opposes the work done by any force which opposes the direction of motion of a body are called negative work. Okay, so one example of negative work is work done due to frictional force. Okay, so when you move an object, okay, when you move an object in some rough surface, it is always a frictional drag. Okay, so in this case, what we do, net force. Okay, how we calculate net force? F is equal to F minus F1. Okay, this is a net force. So in such cases, this minus F1 or F1 is the negative work. Okay, it opposes the direction of motion of this object. Okay, it opposes the direction of motion. Okay, sorry, it opposes the motion of this object. Okay, this frictional force opposes the motion of this object, so this is called negative work. Okay, and in these cases, work done will be how much? F net into distance displacement. Okay, and F net is what? F minus F1. So this is all about the work. Okay, and next thing is kinetic energy. Okay, so we can express kinetic energy as half m v dot v. Okay, dot product of velocity vectors. Okay, dot product of velocity vector, or half of and magnitude of the velocity vector, square of the magnitude of the velocity vector. Okay, so this is how we represent the kinetic energy. Okay, so what is kinetic energy? So it is the measure of work that an moving object can do. Okay, so what is kinetic energy? In simple word, it is the measure of work that a moving object can do. Okay, kinetic energy is the measure of the work that a moving object can perform or can do. Okay, so this is the kinetic energy, and this is how we represent the kinetic energy term. Okay, so suppose m is the mass of the object, and v is the velocity of the object at which it is moving. Okay, and k is the kinetic energy. Okay, so now up to now what we discussed, up to now we discussed work done by constant force. Up to now the force, up to now what we discussed in all the cases, how to discuss the force applied is constant. Okay, constant force. Okay, if the force, the vector is what? It is constant force. Okay, up to now the work done, up to now how to discuss the work done by constant force. Okay, so what is constant force? Suppose if we draw force and displacement. Okay, force and displacement graph. So in case of constant force, what happens? Force is constant during the displacement. Okay, during the whole displacement, the force remains constant. Okay, so suppose I am giving an example. Suppose there is an object and you are moving the object by applying a force equal to 100 Newton. Okay, suppose you are displacing this object from x is equal to 1 meter to x is equal to 6 meter. Okay, you are displacing this object of mass m from x 1 meter to from x equal to 1 meter to x equal to 6 meter by applying a force, constant force F. Okay, during the whole pass. Okay, so constant force means what? The force is constant. Okay, the force is same or uniform during the whole displacement. Okay, constant force is what? Force is uniform. Okay, during the whole displacement. So what is constant force? Constant force. In constant force, force is uniform. Force applied on the object is uniform during the whole displacement. Okay, so this is the example of uniform force. Okay, so in this case, see, if we have to calculate a work done, what we do? W is nothing but the force into displacement. So 1 minus is 5. So what will the work done? We have 500 Newton. Okay, so this is how we proceed. Okay, for in case of constant force. Okay, so force is equal to constant force. Force is uniform during the whole displacement of the object. Okay, so so this is a simple case actually. Okay, so if you see the graph, see in case of constant force, what happens? The force remains constant during the whole displacement of the object. So if we are asked, suppose x equal to 0, so here say this position is x equal to 5. Okay, suppose we are asked to calculate work done from this graph. We are asked to calculate work done in displacing the object from x equal to 0 to x equal to 5. Suppose this position is 10 Newton. Okay, so from this graph we are asked to calculate the work done displacing the object Okay, work done is displacing the object from x equal to 0 to x equal to 5. So what we do? We simply do f into d. Okay, f dot d or f into d. Suppose the force and displacement are in the same direction. Okay, in this case, same direction. So how we calculate f dot d? F is 10 Newton and d is what? 5. Yes, we get 50 Newton. Okay, so see, if we see the graph, if we join this is a rectangle. Okay, this is a rectangle O A B C. Okay, so what is the area of the rectangle? Area is how much? Length into breadth. Okay, length is 5. Sorry, length is suppose, okay, 5 into 10. Okay, so what it is? 50. Okay, so when you proceed graphically, okay, so when you proceed graphically, okay, in case of force and displacement graph, okay, when you proceed graphically, in case of force and displacement graph, work done is nothing but the area under the force fx graph. Okay, okay, work done is nothing but the area under the fx graph curve. Okay, fx curve. Okay, so if you see the graph, work done is what? Area of this rectangle. Okay, so from here we can say that graphically work done is nothing but the area under the fx curve. Okay, this is the fx curve. Okay, for constant force, f is a straight line parallel to x-axis, parallel to displacement axis. So work done is nothing but the area under this fx curve. So this is the case for constant force. Okay, if we now we go for work done by variable force. Variable force. Okay, so what is variable force? Okay, if force is not uniform, if force is not uniform during the displacement of the object. So what is variable force? If the force is not uniform during the displacement of the object, okay, if the applied force is not uniform during the whole displacement of the object, then it is called variable force. Okay, suppose if we see the graph of variable force, so what is variable force? Variable force is how we represent this? We represent it as fx. Okay, fx means it's a function of x. Okay, when x changes, the force will, or when displacement changes, the force will also change. Okay, that is, force is here, force is a function of displacement, and we represent this as fx. So in the variable force, how we represent this? Fx. Okay, this direction, and x is displacement in x direction, in this direction. So earlier case was constant force. So in case of variable force, what we get? We get curve like this. Okay, that is, force is not uniform. Okay, force is not uniform during the displacement of the object. Okay, we see the curve, force is not uniform during the displacement of this object. So this is called variable force. Okay, this is called variable force. Okay, and we have to calculate the work done. We have to calculate the work done. We have to calculate the work done by variable force. Okay, so here in this case also, what we have to what is the motive, or what we have to go? We have to go for the calculating the area under this fx curve, okay, or force displacement curve. Okay, here also in this case, for calculating the work done, we have to do what? We have to calculate the area under this force displacement curve. Okay, this is the work done. Okay, this will be the work.